Okay, so let's look at number 9. Number 9 says that from a bedroom window, a girl drops a water balloon to the ground below, which is 6 meters. And it was released from rest. And so we want to know how long is the balloon in the air. Well, D equals 1/2 AT squared plus VIT. That's going to go away because VI is 0, so 6.0 meters equals 1/2. A is gravity, 9.8. So when I did that math, I got T to be 1.11 seconds. All right, number 10. Number 10 says you have a wrecking ball is hanging at rest from a crane when suddenly the cable breaks. The time it takes for the ball to fall halfway to the ground is 1.2 seconds. Find the time it takes for the ball to fall from rest all the way to the ground. And there's a typo on that page, so you might want to fix that. So VI is 0 if it falls from rest. And for 1.2 seconds, it covers half the distance. So let's call that D1. So let's calculate D1. This is 0. So D1 is going to be 1/2 gravity, 9.8. T is 1.2. Square that and solve for D1. And D1 is 7.06 meters. So all the way to the ground would be twice that much. So 2 times 7.06 meters would be 14.12 meters. So I'm going to do the exact same equation. And I'm going to start it from rest again. This time I'm going to let the ball fall all the way to the ground. So 14.12 meters equals 1/2, 9.8. T squared. So I solved for T, and I believe I got 1.7 seconds. And I solved for T. Let me check. Yes, I did. All right. That was number 10. We're going to move on to number 11. Number 11 said, a penny is dropped from rest from the top of the Sears Tower in Chicago. Considering the height of the building is 427 meters and ignoring air resistance, find the speed with which the penny strikes the ground. Well, VI is 0. D is 427 meters. Let me double check. Yes, 427 meters. Acceleration is just gravity. And they want to know VF. Now, when you first read that problem, this is the only value you're given. And then you realize, oh, it's from rest. And so there's really a lot more there than you actually are given. You just have to think about it. So VF squared equals VI squared plus 2AD. This is 0. So VF is going to be the square root of 2AD. So I solved for that speed, and when I got that, I got 91.5 meters per second. So there's number 11. Okay, let's go on down and take a look at 12. Let's change the color. There we go. Okay, number 12. Number 12 says, at the beginning of a basketball game, a referee tosses the ball straight up with a speed of 4.6 meters per second. The player cannot touch the ball until after it reaches its maximum height and begins to fall down. What is the minimum time that a player must wait before touching the ball? So basically they're asking me how long does a ball rise for. So again, they don't give me a whole lot of information. They tell me that he tosses it upward at 4.6 meters per second. The final speed at the highest point is going to be 0. And we're looking for the time. So VF equals VI plus AT. A is, of course, negative gravity because it's slowing it down. So 0 meters per second equals 4.6 meters per second plus negative 9.8 meters per second squared, t. So I took t and to get t, I took 4.6 and brought it over here, made it negative, divided by negative 9.8, solve for t, got 0.47 seconds. All right, let's move on to number 13. Number 13 says, a bicyclist makes a trip that consists of 3 parts, each in the same direction along a straight road. During the first part, she rides for 22 minutes at an average speed of 7.2. During the second part, 36 minutes, average speed of 5.1. Third part, she rides for 8 minutes at a speed of 13 meters per second. How far has she traveled, and then what's her average velocity? So I have to do some work and look at it in parts again, which we've done before, so that's not any big deal. So let's see. That color's a little light. So I think I'm going to go with something a little bit darker. Lovely shade of burnt orange, if there is such a thing. Okay, so 13 says that she has 22 minutes of travel, and that 22 minutes of travel is covered at 7.2 meters per second. So I'm going to go ahead and get rid of those minutes and multiply by 60, and I think that's going to give me 1,320 seconds. And then T2 lasts for 36 minutes. And again, the minutes don't do anything for me, so that's going to be 2160 seconds, if I did my math correctly. B2 is going to be 5.1. And then T3 is 13 minutes. And 13 times 60 should give me 780 seconds. And she covers that trip at 13 meters per second. So V3 is 13 meters per second. All right, they want me to find the total distance and her average speed. So total distance is going to be D1 plus D2 plus D3. So D1 is going to be 7.2 times 1320. D2 is going to be 5.1 times 2160. And then D3 is going to be 13 meters per second times 780. So when I did that, I got 9504 here. And then I got 11,016 here. And then I finally got 6240 here. So when I added those all up, I got 26,760 meters. So there's your total distance. And then the average speed for part D is so easy. Distance total over total time. Distance total is 26,760 meters. Total time, well, I'm going to add all of those up. And when I added those all up, I got 3,960 seconds. So her average speed was 6.8 meters per second. All right, we have number 14. I think that's our last one. Okay. We've already done one like number 14 when we did the one in class. I think it's number 41 or 46 off of that worksheet from chapter 2, but we'll do it again. I'll do another one. A roof tile falls from rest, so VI is rest. And the top of a building, an observer inside the building notices that it takes 0.2 seconds for the tile to pass her window, whose height is 1.6 meters. How far above the top of this window is the roof? So here's my roof. They want me to give them this distance right here. And this is what I know, 1.6 meters. Time is 0.20 seconds. All right, so I played with it and said, well, let's find BI. So D equals 1/2 AT squared plus VIT, because I know everything. So 1.6 meters equals 1/2. Gravity is my acceleration. T is 0.20 plus VI, I don't know. And then T is still, and that looks goofy. See if we can fix that. 0.20. So when I did all that work, I solved for VI and I got 7.02. But let me explain to you where that VI is on this picture. That VI right there is in that direction. It's also the VF that it fell, or that it acquired as a result of falling my mystery distance. So now I can go back and find my mystery distance. So VF squared, VI squared, 2AD. VI is going to be 0 because it was released from rest up here. VF was my 7.02. Oops, not good math. Let's get rid of that. Equals 2, A is 9.8. D. And then I squared my 7.02 and divided it by 19.6. So 49 divided by 19.6 should be about 2.5 meters. And that's reasonable because this is close to 50, that's close to 20, so my distance is very reasonable of 2.5 meters. All right, please study.